Okay, so I've written a little routine here that includes our manual alignment and our DCC alignment. And in the process, I have also put in a few move commands, which I haven't shown you yet. Move commands allow me to put the probe in a certain location so that it won't crash into the part. For instance, if I'm making a measurement here on the part, and then I tell it to make a measurement over here, it's going to try to go right through the part to get to that spot. So that will crash the probe. What I have to do instead is tell the probe to move to about here, and then I insert what's called a move command, which is as simple as saying insert move. Then it will move to this location next before coming down and making another hit. Additionally, I put in comments so that the operator knows what to do when we're making a manual alignment. So I'm going to start off checking this little green triangle here is like the play button. It is execute. So when I do that, the first thing it tells me is please rotate to ID T1, A0, B0. A0 and B0 are these commands. A is the angle and B is the rotation. It's telling me to keep them both at 0, which they are. All I have to do is click OK and it goes away. Now I get my little comment message that says measure 3 points on the top plane. I say OK, pick up the jog box, bring it over, get it close, put it in turtle mode, and start to make my hits on it. There's 1, here's 2, here's 3. I say, okay. I stored that, now it says measure 3 points on the front plane. I say, okay. Because I am the operator at the moment. Make 3-point hits, doesn't matter where, any 3 will do. Again, I check, okay. Now it says measure 3 points on the left plane. So I will take this out of turtle so I can move it a little quicker. Put it back in turtle. Get close. Bing. Bang. Boom. So I have done my bit now. Now that move command takes the probe up out of the way, so it doesn't just crash right into the part. And now it's going to make its DCC measurements. It's going to take 6 hits on the top plane. And it's showing it on the CAD drawing as well as on the part. Again, I moved the probe. Here it is taking 6 hits on the front plane. Again, I move the probe to a safe place, and it goes ahead. It's going to just take 4 hits on this particular plane. So, and then I moved it again at the end, because whatever routine I want to do from there is going to probably make the probe crash. So I had a little forethought and made that happen. So now we are down here at the bottom of all of this. We have made our last move and we have completed our alignment. And now because I moved the probe there, you can see where we were last. So we have our trihedron showing up here in this corner of the drawing, and so all is good. So I could make measurements manually at this point by using the jog box and storing them, or I could just go crazy and start measuring these things using the this CAD model that we have right here. This makes life simple just to work from the CAD model. So I think I will largely do work here. So these are all measured features. So if I want to measure a point, you know, if I want to know a point in space like this particular little red hole here, this is actually a little threaded spot here. I could click right on this and then store it. Okay, I'd say that. I don't think you didn't really get it. Let's try, I'm sorry. I need to select this little probe icon here first. Then I can click on it. Then I can accept it. And it now says 0.1. So I have measured a point in space. If I want to measure a line, I can flip the model to wherever I want and I can make a measurement. So for instance, if I wanted to measure from this corner right here to this bend right here and accept it, it comes up as a line. Now if it had not guessed correctly, and this does happen if you're using the guess function here, there is a way to fix it. You can come up here to, and I have to find this, edit, override guess. And then it gives you a listing here: circle, line, plane, cylinder, cone, sphere. You pick which one it is, or what it's supposed to be, and it will change that command line to what it should really be. So let's try that out. If I'm here, I've measured a line. I'm going to put it on guess, and I'm going to move this around here a little bit so I can get into it. I'm going to try to make 3 hits on a circle here, using the mouse. And you know, you can blow this up if you can't really see what you're doing. And there, I have made 3 hits on a circle, and I'm going to accept it. What did it come up with? It came up with circles, so it was correct. But it could have come up with something entirely different. It may have figured that that was a plane. If I had gotten all 3 of those hits in exactly the same location front to back, it might have thought I was in a plane instead of a circle. So sometimes you have to correct it. So that's how all of these measured features work right here. And they will appear here as you are doing those. So let's talk about a constructed feature next. Okay. So here's a good spot to work this little V notch right here. I could go ahead and measure 2 lines in here using the measured line feature. I can go ahead and stick one there and one there and call it and it's a line. It's line 2 now. And then I can move this around and click 2 on this other face right here. And click accept. And so now I have line 2 and line 3. Now let's see what we can do with that. I can come up to these constructed features. So for instance, constructed line. And it's going to come up with this dialog box here that says constructed line. What do I want to do with it? Well, what I want to do is create line 4 here using line 2 and line 3, and they are sort of in their own planes there. So if I say create, it comes up with line 4. If we want to look at where that feature is, well, let's see if I can get the probe up out of the way here. Let's just move it. Okay, this is not going to be that simple. I'm just going to put it over here somewhere. Delete that hit. We have now created a line between these 2 features here. Line 2, line 3, line 4. So you can see how that line is in the middle here now. I could have done the same thing with planes. Okay, so if I construct planes over here, so I need 3 hits to make it a plane. It don't necessarily have to be in a line. Accept it. I now have plane 7. I'm going to make another one over here. Plane 8. And then I construct a line between those. So it says line 5. And I'm going to use plane 7 and plane 8. I want it to make a 2D line. And I want to have it as the intersection of those two planes. So instead of just drawing a line between two lines, it's now looking at the intersection of these two planes. So if I create that, probe over to somewhere else here, so we can get a sense. We now show that there's a line right up the center of that thing. It is the intersection of these two planes. So these constructed features work like this. You could make a circle, you could construct a circle on the top surface. Let me get this a little more centered here. I'll move the probe up out of the way. At that point. So say I wanted to construct a circle made up of the centers of all of these cylinders right here. I could measure all of these cylinders, and because they're diameter-based things, I could then construct a circle which would go through the center point of every one of those circles. So if I wanted to know the diameter of this ring of circles, I could construct a circle. So that's how constructed features work. You can construct a feature from anything that you see on there that makes sense to you. And this is a great way to measure things that aren't really readily measurable otherwise. Well, let's talk about this last set of features here. These are auto features. So these things are particularly good if you want to measure a cylinder. So for instance, this thing is 3 nested cylinders here. I don't know if you can see it very clearly in the drawing on camera here, but there are 3 separate cylinders there. Say I want to just measure this top cylinder without actually going in there and measuring them all by hand. Now you might remember that to measure a cylinder it wants to take 3 points around minimum near the top and then 3 random points within the cylinder. We can tell it to do an auto feature here, an auto cylinder, by clicking on that. Now, it comes up with this whole auto feature property box here, and in it, there's a lot of data in here. You need to know which surface you're looking at, what the angle is that you're approaching, theoretically. And then there are some theoretical numbers in here about what the sizes of these things are. Then at the bottom here it asks you hits per level, depth, ending offset, levels, and pitch. So yeah, there's a lot of stuff going on in here. What they're saying is if you have 5 hits per level, it's going to take 5 hits around inside of there. I think I would lower it to maybe 3 hits per level. And it's saying, what's the depth? The depth is how far down from this top surface is it going to start measuring. And the ending offset is how far up from the bottom is it going to measure. And the levels are how many levels of measurement around are you going to make. So yeah, there's a lot of information going on here. And the only way to do it is to go ahead and test it. So, look, the probe's way over here somewhere. It doesn't know what the heck's going on. I needed to give it some information first. So, let's stop, okay? I'm going to close this temporarily. I'm not going to create that feature. What I'm going to do instead is come over here and put a point right there, right at the top. Probe that, right there. Okay, so that's at the edge of that part now. I'm going to move this probe up so it's up and out of the way so we can do something when it comes time without crashing. Now I'm going to hit auto cylinder. I'm going to say test. So why did it go way over there, you ask? Oh, because I don't have correct information in it still. And it says error. Okay. How do we get this right? There's a number of features here that we haven't really set up correctly. And some of that is, where's the location of this particular cylinder? So we need to give this some information. The center of this thing is right there. If I click in it, now you can see that there's a number of levels of information inside of there. It has now found the center of this particular feature here, and I have now got a lot of information in here about how this is going to work. So we can test this again now and see what it will do. Notice how the probe knows to move down inside now and start making measurements within it. This is a great feature when you're programming using the probe, but there's a lot of drawbacks. There's a lot of features and information that you have to put in there for it to work correctly. Obviously, we didn't tell it the correct offset distances and all of the information about that hole. So once again, it says there's an error. But that's why you test these out. It gives you the chance to go and play with it and make sure that you get it right before you actually create the feature. So none of this will work until you've tested it and it has worked properly. So yeah, it's kind of great, it's kind of nifty, but it takes some practice to get it to work correctly. Certainly measuring things more directly ensures a greater degree of success. But if you become a really good programmer, you can use these auto features and save yourself a lot of time plunking hits in and around things. Because there's no guarantee that when the thing runs, even if you've done manual placement of hits, that it's going to fully work correctly. You do have to keep testing this as you move along. So anyway, there's a little flavor of how this stuff works. I hope you feel like you got a little bit out of this lesson. And ultimately you will have to try it for yourself and play around with it until you're comfortable with how it works.